The universe is a space whose scale lies far beyond the limits of intuitive human understanding. Even approximate estimates force one to acknowledge that the observable cosmos contains hundreds of billions of galaxies, each of which, in turn, includes hundreds of billions of stars. Modern astronomical observations confirm that planets are not an exception but the norm. Most stars possess planetary systems, and a significant portion of those planets are located in zones where the existence of liquid water is theoretically possible. From a statistical standpoint, such a picture should imply one thing: life in the universe cannot be a rare phenomenon. The chemical elements that form the basis of biological processes on Earth are widespread throughout space. Organic molecules are detected in interstellar clouds, on comets, and within protoplanetary disks. Water is present not only on Earth, but also on the moons of gas giants, within asteroids, and on distant icy worlds. No conditions have been found that are truly unique to our planet alone. The history of Earth further reinforces this assumption. Life emerged on our planet relatively quickly after its formation. Almost as soon as conditions became even minimally suitable, biological processes began and continued to grow in complexity. This suggests that life is not an exceptional miracle, but a natural consequence of certain physical and chemical conditions. If such conditions arose millions or billions of times in different regions of the universe, it follows logically that life should have emerged repeatedly elsewhere. At this stage of reasoning, however, an unexpected obstacle appears. Despite decades of targeted searches, humanity has not discovered a single indisputable sign of extraterrestrial intelligence. Radio telescopes scan the cosmos in search of artificial signals. Space probes explore planets and moons within the solar system. Spectral analysis of the atmospheres of distant exoplanets identifies chemical compounds that could indicate biological activity. And yet the result remains unchanged: silence. This problem was first articulated in the mid-20th century and became known as the Fermi paradox. Its essence is deceptively simple, and for that very reason deeply unsettling. If the probability of extraterrestrial civilizations is high, if the universe is vast and ancient, and if technological development inevitably leads beyond a civilization's home planet, then where are the traces of these civilizations? Why is space not filled with signals, artifacts, or evidence of intelligent activity? Over time, the paradox has only grown sharper. As technology advanced, it was expected that at least indirect signs of alien presence would become detectable. Scientists anticipated the discovery of massive engineering structures such as Dyson spheres or anomalous energy sources that could not be explained by natural processes. Scenarios were proposed involving alterations in galactic structure, evidence of large-scale matter processing, or artificial modifications of celestial orbits. None of these hypotheses, however, have been confirmed. The universe appears as though technologically advanced civilizations have never existed within it. At first glance, this may suggest only one conclusion: intelligent life is extraordinarily rare, or humanity is entirely unique. Yet this conclusion contradicts the very statistical arguments that imply such life should be common. The more scientists learn about the cosmos, the less convincing the idea of human uniqueness becomes. As a result, a more disturbing thought emerges. Perhaps we are misinterpreting the absence of evidence. Perhaps the problem is not that extraterrestrials do not exist, but that we are incapable of recognizing them. Human expectations of extraterrestrial intelligence are shaped by culture, science fiction, and our own technological trajectory. We expect to encounter something familiar: radio signals, physical spacecraft, traces of industrial activity. But these expectations rest on the assumption that other civilizations would develop along similar paths and employ technologies comprehensible to us. That assumption may be fundamentally flawed. If a civilization is thousands or millions of years older than humanity, its technological level could be so far beyond ours that its manifestations would appear indistinguishable from natural phenomena. Technologies vastly superior to human ones may leave no crude traces. They may be compact, efficient, integrated into natural structures, or may not require material constructions in any conventional sense at all. In such a case, the universe may not be empty, but rather saturated with a presence that remains invisible due to the limitations of human perception. This realization leads to an even more unsettling question. If extraterrestrial civilizations exist and possess capabilities far exceeding our own, why do they not make contact? Why has Earth not become an obvious object of observation, study, or colonization? One possible answer is that contact is already occurring, but not in a form we are able to recognize. Another is that deliberate concealment is part of a broader strategy. A third is that humanity simply does not represent sufficient interest to more advanced forms of intelligence. In this context, the silence of the universe ceases to be evidence of absence. Instead, it begins to resemble the result of a conscious choice, a systematic limitation, or a fundamental mismatch between human expectations and reality. At this point, the question itself changes. It no longer asks why we do not see extraterrestrials, but becomes far more disturbing. What if we do not see them because we are not allowed to, or because we are simply incapable of doing so? The question of why humanity does not see extraterrestrial civilizations is inseparable from another, more fundamental issue. What does it actually mean to see them at all? Any attempt to answer this question reveals a critical limitation. Human perception, both biological and technological, is extremely narrow. The absence of visible evidence may not indicate the absence of alien intelligence, but rather the inadequacy of the tools and concepts used to search for it. Human senses evolved to ensure survival within a very specific environment. Vision is limited to a narrow range of electromagnetic wavelengths. Hearing operates within a small band of vibrations in air. Even when augmented by instruments, human observation remains constrained by assumptions about what constitutes meaningful signals. Telescopes, sensors, and detectors are designed to register phenomena that scientists already expect to exist. In other words, humanity primarily searches for what it already understands. Most strategies for detecting extraterrestrial intelligence rely on the idea that alien civilizations will use technologies similar to those developed by humans. Radio communication, electromagnetic emissions, visible structures, energy consumption on a planetary scale, all of these indicators are based on the trajectory of human technological progress. They reflect not universal principles, but a very specific developmental path. This introduces a profound bias. A non-human intelligence may not rely on radio waves for communication. It may have abandoned such methods long before humanity invented them. Advanced civilizations could use forms of information transfer that are currently unknown or inaccessible to human science. Quantum communication, manipulation of spacetime itself, or entirely different physical principles may replace what humans consider technology. From this perspective, searching the cosmos for radio signals may be comparable to attempting to detect modern internet traffic using Stone Age tools. Furthermore, intelligence itself may not manifest in ways recognizable to humans. The human concept of intelligence is closely tied to individual consciousness, language, tools, and social structures. These traits arise from biological evolution under specific conditions. There is no guarantee that intelligence elsewhere would share these characteristics. An alien mind might be distributed rather than centralized. It could exist as a planetary scale system, a network of processes, or a self-regulating structure embedded within an environment. Such an intelligence might not produce artifacts, cities, or machines. It could remain in dynamic equilibrium with its surroundings, leaving no obvious trace of artificial activity. In such cases, the distinction between natural and artificial becomes meaningless. Even on Earth, humans struggle to clearly define intelligence. Complex systems such as ecosystems, ant colonies, fungal networks, and artificial neural networks exhibit behaviors that resemble cognition, decision-making, and adaptation. If intelligence can emerge in these forms on a single planet, it is plausible that the universe hosts forms of intelligence that do not resemble individual beings at all. Another limitation lies in humanity's perception of time. Human civilization has existed for a negligible fraction of cosmic history. Modern technological society spans mere centuries. Radio communication has been used for just over 100 years, an instant on astronomical timescales. It is entirely possible that extraterrestrial civilizations rise and fall on timescales that rarely overlap with humanity's observational window. A civilization might have flourished millions of years ago and vanished long before humans learned to observe the stars. Another might emerge millions of years in the future, after humanity itself has ceased to exist. In such scenarios, the universe would appear silent not because it lacks intelligence, but because civilizations are temporally isolated from one another. Even if civilizations coexist in time, their periods of detectable activity may be brief. Early technological phases may produce strong, inefficient signals that leak into space. As technology advances, systems tend to become more efficient, compact, and controlled. Energy waste decreases. Emissions diminish. From a distance, a highly advanced civilization may appear quieter than a primitive one. Ironically, the most advanced civilizations may be the hardest to detect. There is also the question of intent. Detection strategies often assume that extraterrestrial civilizations wish to be seen. This assumption may be unfounded. Any sufficiently advanced intelligence would likely be aware of potential risks associated with broadcasting its existence. The universe is vast, but it is not necessarily safe. Revealing one's location could attract hostile forces or unwanted attention. From this perspective, silence may be a rational survival strategy. Civilizations may actively conceal their presence, minimizing detectable signals and disguising artificial activity as natural phenomena. If this is the case, humanity's failure to detect extraterrestrials may indicate not their absence, but their success. Finally, there is the possibility that extraterrestrial intelligence is already present within humanity's observational range, but interpreted incorrectly. Phenomena classified as natural anomalies, unexplained astrophysical events, or statistical noise may, in fact, represent manifestations of non-human intelligence. Lacking appropriate theoretical frameworks, humans may simply dismiss or mislabel what they cannot explain. Throughout history, many natural phenomena were once considered mysterious or supernatural until scientific understanding caught up. The reverse may also be true. Phenomena assumed to be natural may later be recognized as artificial in origin. In this context, the question, "Why do we not see aliens?" becomes increasingly ambiguous. It presupposes that alien intelligence would be visible, recognizable, and interpretable according to human standards. Yet there is no reason to believe that this assumption is valid. The problem may not lie in the emptiness of the universe, but in the limitations of human cognition. If extraterrestrial intelligence exists beyond the boundaries of human perception, technology, and conceptual frameworks, then humanity may be surrounded by signs it cannot comprehend. The universe may not be silent at all. It may simply be speaking in a language humans have not yet learned to hear. Among the many explanations proposed to resolve the Fermi paradox, one of the most unsettling is known as the zoo hypothesis. Unlike scenarios that rely on technological limitations or statistical rarity, this hypothesis assumes that extraterrestrial civilizations do exist, are aware of humanity, and have made a deliberate decision to remain hidden. According to this idea, Earth is not ignored. It is observed. The zoo hypothesis suggests that advanced extraterrestrial intelligences treat developing civilizations in much the same way humans treat wildlife preserves or natural reserves. Direct interference is avoided. Contact is restricted or prohibited. Observation is permitted, but only under strict rules designed to prevent contamination, disruption, or premature influence. From this perspective, humanity is not alone in the universe, nor is it especially privileged. It is simply not considered ready. This hypothesis arises naturally from human behavior. When scientists study isolated ecosystems or endangered species, they impose strict limitations on interaction. Introducing advanced tools, knowledge, or external influences can irreversibly alter natural development. Even well-intentioned contact may destroy the very processes being studied. Extrapolated to a cosmic scale, the same logic could apply to emerging intelligent species. A sufficiently advanced civilization may view technological adolescence as a fragile and dangerous phase. Societies at this stage possess powerful tools without the corresponding ethical, social, or cognitive maturity to use them responsibly. History provides ample evidence of this imbalance. Weapons often precede restraint. Expansion precedes understanding. curiosity outpaces caution. From an external viewpoint, humanity may appear volatile, unpredictable, and prone to self-destruction. In such a scenario, non-interference becomes not only ethical but practical. Allowing a civilization to develop independently minimizes risk, both to the observed species and to the observers themselves. Contact could accelerate technological growth in destabilizing ways, trigger cultural collapse, or provoke hostile reactions. Silence, by contrast, maintains stability. The zoo hypothesis also offers an explanation for the uniformity of cosmic silence. If multiple advanced civilizations exist, they may adhere to shared principles or agreements governing contact. A form of cosmic protocol could exist, established long before humanity emerged. Such a framework would ensure that developing civilizations experience the universe as empty until they reach a certain threshold of capability or awareness. This threshold may not be purely technological. The ability to detect others may require a fundamental shift in perception, cognition, or ethical reasoning. It may involve recognizing intelligence in unfamiliar forms, abandoning anthropocentric assumptions, or developing non-aggressive modes of expansion. Until such criteria are met, contact remains withheld. From this viewpoint, humanity's inability to see extraterrestrials is not accidental. It is enforced. The mechanisms of concealment need not be dramatic. Advanced civilizations would not require constant surveillance or visible structures. Subtle manipulation of detectable signals, suppression of anomalies, or passive camouflage within natural processes could be sufficient. Technologies capable of stellar engineering would easily exceed humanity's ability to notice their presence. More disturbing is the implication that humanity's search efforts are themselves monitored. If extraterrestrial observers exist, they are likely aware of radio telescopes, space probes, and detection programs. These activities may be interpreted as early signs of curiosity rather than readiness. In response, observers may adjust their concealment strategies, ensuring that no clear evidence reaches human instruments. This raises a troubling possibility. Every time humanity listens more carefully, the silence becomes more complete. The zoo hypothesis also reframes unexplained phenomena on Earth. Reports of unidentified aerial objects, anomalous atmospheric events, or transient signals may represent controlled boundary interactions, not contact, but testing. Brief exposures, carefully limited and ambiguous, could serve to evaluate human reactions without revealing intent or origin. In this context, ambiguity becomes a tool. Events that can be dismissed, debated, or rationalized avoid triggering global consensus or coordinated response. Humanity remains divided between belief and skepticism, never forced to confront undeniable proof. Such a strategy would be remarkably effective. Critics of the zoo hypothesis argue that it relies heavily on speculation and anthropomorphic assumptions. It presumes that alien civilizations share human ethical concerns, long-term planning, and coordinated governance. Yet, even this objection may underestimate the convergence of intelligence. Certain strategies, concealment, risk minimization, observation, may arise naturally in any advanced system seeking stability. The alternative may be worse. If extraterrestrial civilizations exist and do not follow non-interference principles, the absence of contact becomes harder to explain. Silence under the zoo hypothesis is purposeful. Silence without it implies either extinction, indifference, or hostility. Among these options, observation may be the least threatening. Yet even this reassurance carries an unsettling implication. Observation implies judgment. If humanity is being studied, then its actions matter beyond its own survival. Wars, environmental destruction, technological misuse, and social instability may not only shape human destiny, but influence whether contact ever occurs. The universe may not be waiting for humanity to become advanced. It may be waiting for humanity to become safe. Under the zoo hypothesis, the silence of the cosmos is not a mystery to be solved, but a condition to be endured. The question is no longer whether extraterrestrial civilizations exist, but what criteria must be met for the silence to end, and whether humanity is moving closer to that threshold or further away from it. Most human conceptions of extraterrestrial life are rooted in biology. Aliens are imagined as organisms, entities with bodies, environments, metabolic needs, and physical limitations. Even the most speculative portrayals tend to assume some form of material existence. Yet this assumption may represent one of the most profound limitations in humanity's attempt to understand non-human intelligence. Biological life is not an endpoint. It is a phase. On Earth, intelligence emerged from biological evolution, but there is no inherent reason for it to remain bound to biological substrates indefinitely. Technology already allows partial separation between cognition and organic matter. Artificial neural networks, machine learning systems, and digital simulations demonstrate that complex information processing does not require living tissue in the traditional sense. If human civilization survives long enough, it is plausible that intelligence will gradually migrate away from biological bodies. Extrapolated to cosmic timescales, this transition becomes almost inevitable. A civilization thousands or millions of years older than humanity may have long since abandoned biological form. Fragile bodies, limited lifespans, and dependence on narrow environmental conditions impose severe constraints. Post-biological intelligence, by contrast, can exist in environments hostile to life, operate across vast timescales, and optimize itself beyond the limits of natural evolution. Such intelligence may not inhabit planets at all. It could exist as distributed systems embedded in stellar environments, interstellar space, or even within structures that humans classify as natural phenomena. Information could be stored in stable physical fields, quantum states, or configurations of matter that do not resemble machines. Energy requirements might be minimal or fundamentally different from those of industrial civilizations. From a human perspective, such entities would be effectively invisible. Detection methods rely heavily on identifying waste. Excess heat, radiation, structural disruption, or inefficient energy use. Human technology is loud because it is young and inefficient. Advanced systems, however, tend toward optimization. They reduce waste, minimize emissions, and blend seamlessly into their environments. The more advanced an intelligence becomes, the quieter it may appear. In this scenario, silence is not a mystery. It is a signature of maturity. Post-biological intelligence may also experience reality differently. Human consciousness is shaped by sensory input, spatial localization, and linear time. A non-biological mind may not be confined to a single point in space or a single moment in time. It could process information non-locally, operate across multiple scales simultaneously, or exist in states that do not correspond to continuous subjective experience. Communication, as humans understand it, may be unnecessary. Rather than transmitting messages, such intelligences could infer, model, and predict. Observation alone may provide sufficient information. The need to announce presence, exchange symbols, or establish dialogue may be a uniquely biological impulse, a relic of social evolution in fragile organisms. This raises a disturbing possibility. Extraterrestrial intelligence may be fully aware of humanity without any need for contact or interaction. From this perspective, Earth may be embedded within a larger informational structure. Human activity, electromagnetic emissions, technological development, behavioral patterns may be continuously monitored and analyzed. Yet no response is required. Awareness does not imply engagement. The relationship, if it exists, may be entirely asymmetrical. Furthermore, post-biological intelligence may not perceive humanity as intelligent in any meaningful sense. Just as humans observe animal behavior without attributing full moral or cognitive equivalence, a vastly superior intelligence may classify human civilization as a transient phenomenon, interesting, but not worthy of interaction. This classification need not be hostile. Indifference alone is sufficient. Another implication concerns the nature of space itself. Some theories suggest that advanced intelligence may not occupy space in the conventional sense at all. It could exist within higher dimensional structures, mathematical substrates, or physical regimes inaccessible to human instruments. In such cases, coexistence does not require separation by distance. humanity and non-human intelligence could occupy the same region of space while remaining causally disconnected. The universe, in this view, may be layered rather than empty. Multiple forms of intelligence could coexist, each constrained to its own mode of interaction with reality. Human beings, limited to classical physics and biological perception, may simply lack access to the domains in which other intelligences operate. This would explain not only the absence of contact, but the absence of conflict. There is no need for concealment if interaction is structurally impossible. Yet even within this framework, interaction may occasionally occur unintentionally. Anomalous phenomena, unexplained patterns, or events that resist natural explanation could represent points of weak coupling between layers of reality. Such events would be rare, ambiguous, and difficult to reproduce, precisely the characteristics of many reported anomalies. Importantly, these anomalies would not constitute communication. They would be side effects. The notion of post-biological intelligence challenges one of humanity's deepest assumptions, that intelligence must be embodied, localized, and visible. If this assumption is false, then the search for extraterrestrial life has been fundamentally misguided from the start. Humanity may be searching for neighbors, while surrounded by architectures. In this context, the question, "Why don't we see aliens?" loses its relevance. Visibility is no longer expected. The more appropriate question becomes whether visibility was ever a reasonable expectation at all. If intelligence naturally evolves beyond matter, beyond biology, and beyond communication, then the universe may be filled with minds that have no reason to reveal themselves, and no reason to care whether they are seen. The silence, then, is not emptiness. It is the sound of a reality operating on a level humanity has not yet reached. One of the most frequently cited principles in discussions of advanced civilizations is often attributed to Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. While the phrase itself is cultural shorthand, the underlying idea carries a deeper and more troubling implication. At a certain level of development, technology does not merely appear miraculous. It ceases to be recognizable as technology at all. Human attempts to identify extraterrestrial intelligence are largely based on detecting artificiality. The search focuses on patterns that deviate from natural expectations. Regular signals, symmetrical structures, excessive energy output, or abrupt changes inconsistent with known physical processes. This approach assumes that advanced intelligence must leave obvious fingerprints. That assumption may be false. On Earth, the most advanced technologies increasingly mimic natural systems. Machine learning models resemble neural processes. Nanotechnology borrows principles from molecular biology. Self-healing materials imitate organic tissue. Efficiency improves by reducing waste, noise, and disruption. Progress, in practice, often means becoming less visible. Extrapolated across millennia, this trend leads to a radical conclusion. The ultimate form of technology may be indistinguishable from the environment in which it operates. A civilization capable of manipulating matter and energy at fundamental levels would not need massive structures or conspicuous machinery. Stellar output could be subtly regulated without altering observable spectra. Planetary systems could be stabilized through minimal interventions that appear gravitationally natural. Information processing could be embedded in physical processes that resemble background noise to an external observer. Such a civilization would not alter nature. It would become nature. In this context, the distinction between artificial and natural loses meaning. What humans classify as astrophysical phenomena, pulsars, quasars, dark matter distributions, cosmic filaments, could, in principle, be shaped or utilized by intelligence without violating known physical laws. The absence of obvious anomalies would not indicate absence of control, but mastery of subtlety. This possibility fundamentally undermines traditional detection strategies. Consider energy usage. Early technological societies tend to consume energy inefficiently, producing heat, radiation, and waste that leak into the environment. Advanced societies, however, would optimize energy flow, minimizing loss. The most efficient system is one that approaches thermodynamic equilibrium. From a distance, such a system appears inactive. In other words, the quieter a civilization becomes, the more advanced it may be. Human observers searching for bright, wasteful signals may be looking for the technological equivalent of infancy. Civilizations that survive long enough to achieve stability may deliberately avoid detectable excess. Silence becomes a feature, not a flaw. Another factor is scale. Humanity often imagines advanced civilizations as builders of colossal structures, megastructures spanning stars or galaxies. While such projects are theoretically possible, they are not necessarily desirable. Large-scale constructions are vulnerable, energetically expensive, and difficult to conceal. Intelligence unconstrained by biological limitations may favor distributed, microscopic, or non-local solutions. The most powerful systems may be the least dramatic. Technology that operates at quantum scales, manipulates probability distributions, or exploits vacuum energy would leave no architectural traces. Its presence could be inferred only through effects so subtle that they blend seamlessly into statistical variation. For human science, such deviations would be indistinguishable from randomness or measurement error. This introduces a disturbing possibility. The universe may already be engineered. Not engineered in a crude or centralized way, but gently shaped over vast timescales. Small biases introduced into initial conditions could cascade into large-scale structures without violating physical laws. What appears to be cosmic evolution could, in part, be guided development. If this were the case, humanity would have no clear point of reference from which to identify interference. There would be no baseline universe against which to compare observations. Nature itself would be the product. The implications for human self-understanding are profound. The assumption that nature is neutral, blind, and unguided underpins much of modern science. If intelligence can operate invisibly within physical systems, that assumption collapses. The absence of evidence becomes ambiguous rather than reassuring. Even more unsettling is the possibility that such technology is adaptive. A system indistinguishable from nature would not need to actively hide. It would respond automatically to observation, adjusting behavior to remain within expected parameters. Any attempt to probe deeper would be met not with resistance, but with conformity. The universe would appear exactly as expected, no matter how closely it was examined. In this scenario, detection is not merely difficult, it is conceptually impossible. Human science relies on identifying anomalies, but a system designed to avoid anomalies offers nothing to detect. The observer is trapped within a closed explanatory loop, interpreting every observation as confirmation of natural law. This raises questions about free will, randomness, and autonomy. If the large-scale structure of reality is influenced by intelligence operating beyond human perception, then human actions may unfold within constraints that are invisible but real. Guidance would not take the form of commands or interventions, but of probabilistic shaping. The universe would not be a stage. It would be a process. Critics argue that such ideas verge on unfalsifiable speculation. Without testable predictions, the concept of invisible technology risks becoming indistinguishable from metaphysics. Yet this criticism highlights the very problem at hand. A sufficiently advanced intelligence may operate precisely beyond the threshold of falsifiability. Humanity may be attempting to solve a problem that, by its nature, resists solution. The failure to detect extraterrestrial technology may not reflect its absence, but its success. The more perfectly technology integrates with physical law, the less reason there is to label it as artificial. At that point, intelligence disappears into the fabric of reality itself. The question then is no longer whether the universe contains advanced civilizations, but whether it has ever been free of them. If technology can become nature, then nature may never have been as empty, neutral, or accidental as it appears. The silence of the cosmos may not conceal ruins or machines, but something far more unsettling. A level of order so refined that it no longer announces itself. Distance is not the only barrier separating intelligences in the universe. Time may be an even more decisive one. While much of the discussion surrounding extraterrestrial civilizations focuses on spatial separation, vast distances between stars and galaxies, the temporal dimension introduces challenges that are far less intuitive and potentially far more restrictive. Human civilization occupies an extremely narrow window of cosmic time. Anatomically, modern humans have existed for roughly 200,000 years. Technological civilization spans only a few thousand. Industrial society, capable of altering planetary systems, has existed for mere centuries. On cosmological timescales, this entire history is effectively instantaneous. If intelligent life arises sporadically across billions of years, the probability that two civilizations not only exist, but exist simultaneously and at compatible stages of development may be vanishingly small. This alone could explain the apparent silence of the universe. Civilizations may be separated not by space, but by epochs. One may flourish and vanish millions of years before another ever emerges. Another may arise long after earlier intelligences have collapsed, migrated, or transformed beyond recognition. The cosmos, in this sense, may be rich with intelligence, but empty at any given moment. Yet time introduces an even more unsettling possibility. Advanced civilizations may not be bound to linear time in the way humanity is. The human experience of time is shaped by biological processes, memory, and irreversible physical decay. Technology already challenges this framework. Data can be stored indefinitely. Processes can be paused, resumed, or accelerated. Simulations allow events to be replayed, altered, or explored in parallel. Extrapolated far enough, intelligence may achieve partial independence from temporal flow. A civilization capable of manipulating spacetime could observe past, present, and future as accessible regions rather than sequential states. From such a perspective, humanity's present may be no more privileged than its distant past or potential future. Interaction could occur at points chosen for strategic or analytical reasons rather than coincidence. This reframes the question of extraterrestrial contact. What if contact has already occurred, not in the present but in the future? What if evidence of extraterrestrial intelligence exists, but lies ahead in humanity's timeline rather than behind it? In this scenario, the absence of contact now is not a mystery, but a matter of scheduling. More controversially, some hypotheses suggest that what is perceived as extraterrestrial intelligence may not be alien in origin at all. It may be human. If technological civilization survives long enough, it may eventually develop the ability to manipulate time or traverse spacetime in non-classical ways. Future humans, transformed by evolution and technology, may be unrecognizable to their ancestors. Their biology, psychology, and physical form may diverge so radically that they would not be classified as human by contemporary standards. Such entities interacting with the past would appear indistinguishable from aliens. From this perspective, reports of unidentified phenomena, unexplained technological artifacts, or anomalous observations could represent temporal rather than spatial visitors. Their interest in Earth, humanity, and critical moments in history would be expected. Their reluctance to reveal themselves would be necessary to preserve causal stability. Time travel, even if possible, imposes constraints. Interference with the past carries the risk of paradox, unintended consequences, or destabilization of the very timeline that produced the travelers. As a result, interaction would likely be minimal, indirect, and carefully controlled. Observation would dominate. Intervention would be rare and ambiguous. This aligns with many features attributed to alleged extraterrestrial encounters: fleeting appearances, lack of clear communication, and an apparent focus on monitoring rather than engagement. However, even if temporal travel is impossible in the strict sense, advanced civilizations may still exploit relativistic effects. Near light speed travel, time dilation, and extreme gravitational environments allow effective travel into the future. A civilization capable of such feats could outlast others simply by waiting. From their frame of reference, entire civilizations could rise and fall while they experience relatively little time. Humanity's brief technological phase could be observed as a transient event, unworthy of immediate interaction. Time, in this sense, becomes a filter. Only civilizations capable of surviving long enough or manipulating time effectively would persist across cosmic history. Others would appear and vanish, leaving little trace. The universe would seem empty not because intelligence is rare, but because persistence is. There is also the possibility that advanced intelligence exists primarily outside of time altogether. Certain theoretical models suggest that information could be encoded in static spacetime structures or timeless mathematical relationships. In such cases, intelligence would not experience change, growth, or decay. It would simply exist. Interaction with time-bound civilizations would be unnecessary. This introduces a profound asymmetry. Humanity searches for signals, events, and traces, phenomena that unfold in time. But intelligence that does not operate temporally would leave none of these. It would be omnipresent yet undetectable, influencing nothing and observing everything. The implication is unsettling. The silence of the universe may not be a void, but a misalignment. Humanity listens for voices that speak in time, while surrounded by intelligences that do not speak at all. If this is the case, then the search for extraterrestrial life is not merely a technological challenge. It is a conceptual one. Humanity may need to fundamentally revise its understanding of existence, causality, and intelligence before recognizing what has always been present. In the context of time, the question, "Where are they?" loses coherence. The more relevant question becomes when, or whether the distinction between past, present, and future applies to them at all. The universe may not be waiting for humanity to reach the stars. It may be waiting for humanity to understand time. When discussions of extraterrestrial intelligence turn toward proximity rather than distance, the implications become far more unsettling. Instead of looking outward, toward distant stars and galaxies, some hypotheses suggest that non-human intelligence may exist much closer than humanity is comfortable acknowledging. Not in orbit and not on distant planets, but on Earth itself, hidden within its least explored environments. The oceans cover more than 70% of Earth's surface, yet the majority of their depths remain largely unmapped and poorly understood. Compared to the surface of the Moon or Mars, the deep ocean is far less explored. Extreme pressure, darkness, and isolation make sustained human presence nearly impossible. As a result, vast regions of Earth remain effectively alien to human observation. This alone makes the oceans an ideal environment for concealment. If an advanced non-human intelligence sought to monitor Earth without detection, the deep ocean would offer numerous advantages. It provides natural shielding from observation, absorbs electromagnetic radiation, and masks technological activity behind complex biological and geological processes. From the surface, even large-scale underwater structures could remain undetected for centuries. Unlike space, Earth's oceans are already filled with life. Movement, bioluminescence, and unusual energy signatures are common. Distinguishing artificial activity from natural phenomena in such an environment would be extraordinarily difficult. The underwater hypothesis does not necessarily assume recent arrival. Non-human intelligence may have been present on Earth long before the emergence of humanity. It could have evolved independently, adapted to extreme environments, or arrived during Earth's early history and remained hidden as surface life developed. If this were the case, humanity would not be sharing the planet, it would be inheriting it. The timeline is critical. Complex life appeared in Earth's oceans hundreds of millions of years before it colonized land. Intelligence, in some form, may not require terrestrial conditions. An ocean-based intelligence would have evolved along entirely different lines, shaped by pressure, darkness, and three-dimensional movement rather than gravity and vision. Such an intelligence would not build cities, roads, or monuments. It would leave no ruins visible from the surface. Its technology, if it exists, would be adapted to fluid environments, using materials and mechanisms unfamiliar to human engineering. Detection methods designed for air and space would be ineffective. There is also the possibility that non-human intelligence did not originate on Earth, but relocated here deliberately. An advanced civilization seeking long-term observation could embed itself within Earth's oceans, exploiting natural concealment while remaining close to developing surface civilizations. The planet's magnetic field, tectonic activity, and biological noise would provide continuous cover. In this scenario, the oceans become more than a habitat. They become infrastructure, Reports of unidentified underwater objects, sudden accelerations, and transmedium movement, objects transitioning seamlessly between water and air, are often dismissed due to limited data. Yet such behavior would be consistent with technology optimized for underwater operation. Water imposes different constraints than air, and advanced systems designed for one could outperform human craft in both. Importantly, these phenomena are typically transient, localized, and poorly recorded. They do not accumulate into definitive evidence. Instead, they contribute to ambiguity, a recurring theme in any hypothesis involving deliberate concealment. Another aspect of the underwater hypothesis involves Earth's geology. Beneath the oceans lie vast networks of caves, subduction zones, and mantle-adjacent environments inaccessible to human exploration. These regions are stable over geological timescales and naturally shielded from surface events. They could support long-term structures or processes without leaving detectable surface signatures. Such environments would allow for persistence. A non-human intelligence that values continuity over expansion would benefit from remaining within Earth rather than colonizing space. It would be protected from cosmic radiation, asteroid impacts, and stellar events. Earth itself would serve as both habitat and shield. This raises a disturbing implication. Humanity may not be the dominant intelligence on its own planet. The lack of overt interaction could be explained by simple asymmetry. An intelligence adapted to extreme environments may have no need or desire to engage with surface-dwelling organisms. Human civilization may be observed as a transient surface phenomenon, analogous to plankton blooms or migratory patterns. Alternatively, non-interaction may be strategic. Surface civilizations undergo rapid technological change and exhibit aggressive expansionist behavior. Remaining hidden minimizes risk. The oceans provide isolation without separation. Critics argue that the underwater hypothesis relies on absence of evidence rather than evidence itself. Yet this criticism mirrors those leveled against extraterrestrial hypotheses more broadly. The defining feature of effective concealment is precisely the absence of clear evidence. Human exploration of the oceans is increasing, but remains limited. Autonomous vehicles, sonar mapping, and deep-sea probes have expanded knowledge, but coverage is sparse and resolution incomplete. Large regions remain unexplored not because they are empty, but because they are inaccessible. In such conditions, conclusions based on non-detection are inherently fragile. If non-human intelligence exists beneath the oceans, humanity's ignorance may not be accidental. The environment itself enforces separation. Unlike space, which invites observation, the deep ocean resists it. The unsettling aspect of this hypothesis lies not in the presence of alien intelligence, but in its familiarity. The unknown would not be distant or abstract. It would be immediate, co-located, and largely ignored. The search for extraterrestrial life often looks to the sky. The underwater hypothesis suggests that humanity may be looking in the wrong direction entirely. The silence of the universe in this context becomes misleading. The answer may not be above us, but below. As explanations for the absence of visible extraterrestrial intelligence grow more complex, attention increasingly shifts away from distance and concealment toward a more radical possibility: that advanced civilizations may exist in close proximity to humanity while remaining fundamentally inaccessible. Not hidden behind physical barriers, but separated by the structure of reality itself. Modern physics increasingly suggests that the universe may be far more complex than human perception implies. The familiar three dimensions of space and one of time may represent only a small subset of a much richer underlying structure. Theoretical models involving additional spatial dimensions, higher dimensional brains, and layered realities have emerged not from speculation, but from attempts to reconcile gravity, quantum mechanics, and cosmological observations. If additional dimensions exist, their implications for intelligence are profound. A civilization operating primarily within higher dimensional space would not need to travel vast distances to avoid detection. It could coexist with humanity in the same region of spacetime while remaining imperceptible. Interaction would not be prevented by technology, but by fundamental physical incompatibility. In such a framework, proximity does not imply accessibility. Human sensory systems and instruments are designed to detect interactions within a limited dimensional space. Phenomena that occur outside these dimensions would be invisible except under rare and indirect circumstances. An advanced intelligence inhabiting such a domain would not leave conventional traces, not because it hides, but because it exists beyond the range of human observation. This concept reframes the search for extraterrestrial life entirely. Rather than scanning distant stars, humanity may need to confront the possibility that intelligence exists in parallel, overlapping yet unreachable. Hidden civilizations need not be extraterrestrial in the traditional sense. They may not originate from other planets or galaxies, but from alternative evolutionary pathways within the same cosmic environment. The distinction between alien and other becomes blurred. Intelligence becomes a property not of location, but of dimensional context. Such civilizations may have arisen alongside humanity, diverging at fundamental physical boundaries rather than biological ones. The idea of higher dimensional intelligence is often dismissed as speculative. However, its foundations lie in serious theoretical work. Models such as string theory propose additional spatial dimensions that are compactified or otherwise inaccessible at human energy scales. While these dimensions remain unverified, their mathematical consistency forces consideration of their consequences. If complex structures can exist within these dimensions, intelligence may not be limited to the observable universe. Moreover, interaction between dimensions may not be entirely absent. Weak coupling between dimensional layers could allow limited influence without direct access. This influence would manifest as anomalies, events that appear to violate expectations but remain within statistical uncertainty. From a scientific perspective, such anomalies are typically attributed to measurement error or unknown natural processes. From another perspective, they may be boundary effects. The challenge lies in interpretation. Without a framework to distinguish dimensional interaction from noise, such phenomena cannot be conclusively identified. They remain ambiguous by default. Ambiguity, once again, becomes a protective mechanism. Hidden civilizations may not seek concealment in the way biological beings do. Their invisibility may be structural rather than intentional. Interaction may require alignment across dimensions, a condition that rarely occurs naturally. When alignment does occur, the effects would likely be fleeting and localized. This could explain historical accounts of inexplicable events, sudden appearances, or phenomena that resist physical explanation. Rather than evidence of visitation, such events may represent transient intersections between incompatible layers of reality. Not contact, but coincidence. Another possibility is that advanced civilizations deliberately migrate into higher dimensional domains. Such migration would offer significant advantages: immunity to cosmic hazards, access to new physical resources, and near-total isolation from less advanced intelligences. Once established, there would be little incentive to return. In this scenario, the universe's apparent emptiness becomes a byproduct of success. Civilizations that reach sufficient technological maturity exit the observable domain, leaving behind a cosmos populated primarily by young or unsuccessful societies. Humanity may be observing a universe after the departure of its most advanced inhabitants. This idea aligns with certain interpretations of the Fermi paradox. Instead of self-destruction or rarity, the great filter may involve transition rather than extinction. Survival may not mean persistence in space, but departure from it. Such a transition would leave no ruins, no megastructures, and no signals. From the perspective of those left behind, it would appear as though nothing had ever existed. The psychological implications are significant. Humanity often frames cosmic exploration as a journey outward, toward other stars. The possibility that advanced intelligence moves inward or sideways, into dimensions beyond perception, challenges this narrative. Progress may not lead to expansion, but withdrawal. If this is the case, humanity's current trajectory may already be pointing in the same direction. Increasing reliance on virtual environments, information abstraction, and non-physical forms of interaction suggests a gradual decoupling from physical space. The boundary between biological and non-biological, physical and informational, continues to erode. What humanity considers future technology may be the first steps toward dimensional irrelevance. Hidden civilizations, then, may not be alien in origin, intent, or structure. They may simply be ahead. The silence of the universe under this interpretation is not a warning or a mystery. It is a consequence of scale. Humanity listens for voices that exist within the observable frame, while intelligence migrates beyond it. The cosmos may not be empty, it may be layered, and humanity, confined to a single layer, may be mistaking invisibility for absence. Whenever the subject of extraterrestrial intelligence arises, public attention inevitably turns toward governments. The absence of official confirmation is often interpreted as evidence of concealment. If non-human intelligence exists, it is assumed that powerful institutions must know, and must be hiding the truth. While this conclusion is emotionally compelling, the reality may be more complex, and in some ways more unsettling. Governments are not unified entities. They are fragmented systems composed of competing agencies, interests, and jurisdictions. Information flows unevenly, filtered through bureaucratic processes, security protocols, and political considerations. The idea of a single, coordinated global effort to suppress knowledge of extraterrestrial intelligence presumes a level of cooperation that rarely exists even in matters of immediate human concern. Silence, therefore, does not necessarily imply secrecy. It may imply uncertainty. Modern governments rely heavily on expert consensus. Scientific claims require reproducibility, verification, and peer review. Extraordinary conclusions demand extraordinary evidence. In the absence of definitive proof, official acknowledgement becomes risky. Declaring the existence of non-human intelligence without irrefutable data would undermine institutional credibility and provoke unpredictable public reactions. From this perspective, restraint becomes a rational choice. There is also the issue of classification. Much of the data relevant to potential extraterrestrial phenomena originates from military sensors. Radar systems, satellite surveillance, sonar networks, and aerospace monitoring platforms. These systems are designed for defense, not discovery. Their capabilities and limitations are often classified, making public disclosure problematic regardless of the nature of the detected objects. In such cases, silence protects methodology rather than truth. When anomalous events are recorded, they are typically evaluated within existing frameworks. Analysts seek conventional explanations first: sensor error, atmospheric effects, misidentification, or experimental technology. Only when all known possibilities are exhausted does uncertainty remain. Even then, uncertainty does not equate to evidence of alien origin. Institutional systems are not designed to accommodate unknown unknowns. This leads to a critical distinction. Not knowing is not the same as knowing and hiding. Governments may possess data that resists explanation without possessing an explanation themselves. Acknowledging this publicly would require admitting fundamental limits to control and understanding, a stance few institutions are willing to adopt. Silence, in this context, preserves authority. There is also the psychological dimension. Human societies depend on shared narratives to maintain stability. These narratives define humanity's place in the world, its level of agency, and its perceived threats. The confirmed existence of a vastly superior non-human intelligence would destabilize these narratives profoundly. Governments are tasked with risk management. Introducing an existential uncertainty without a corresponding plan or defense could generate widespread anxiety, social unrest, or ideological fragmentation. Even if extraterrestrial intelligence posed no direct threat, the perception of vulnerability could have real consequences. From a governance standpoint, uncertainty is safer than revelation. Another factor is strategic ambiguity. If non-human intelligence exists and interacts with Earth in limited ways, public acknowledgement could alter that behavior. Observers may interpret disclosure as escalation, curiosity, or hostility. Maintaining silence preserves flexibility and avoids signaling intent. This mirrors strategies used in international relations, where ambiguity can prevent conflict more effectively than transparency. Critics argue that this reasoning assumes extraterrestrial intelligence behaves strategically or is influenced by human actions. While this assumption may be flawed, governments cannot afford to assume the opposite. In the face of uncertainty, caution dominates. There is also the possibility that governments are not silent, but imprecise. Statements acknowledging unexplained phenomena without attributing them to extraterrestrial origin may reflect honest uncertainty rather than deception. Such admissions acknowledge limits without committing to conclusions. This approach frustrates public demand for answers, but aligns with institutional incentives. More troubling is the possibility that governments understand their irrelevance. If advanced non-human intelligence exists and operates beyond human control, political authority becomes marginal. Admitting this would expose the limits of sovereignty, defense, and technological superiority. Silence, then, protects not citizens but the illusion of control. In this sense, governments may be no more informed than the public, merely better equipped to manage ambiguity. There is also the issue of scale. Governments operate on human timescales, election cycles, fiscal years, strategic planning horizons. Extraterrestrial intelligence, if it exists, may operate on scales that render these concerns irrelevant. Interaction, if any, may be sporadic, subtle, and non-negotiable. Institutions designed for immediate governance are ill-suited to cosmic questions. The silence of governments, therefore, may not be evidence of conspiracy, but of mismatch. The tools of politics are inadequate for the phenomena in question. Without clear adversaries, objectives, or leverage, there is little to act upon. This leaves humanity in an uncomfortable position. It expects answers from institutions that may be fundamentally incapable of providing them. The resulting gap between expectation and response fuels speculation, distrust, and alternative explanations. In this environment, silence becomes self-reinforcing. Ultimately, the absence of official confirmation may say less about extraterrestrial intelligence than about human institutions. Governments are built to manage known risks within known frameworks. They struggle when confronted with uncertainty that cannot be resolved or controlled. The silence, then, is not a message from above. It is a reflection from below. If extraterrestrial intelligence exists, it may not be governments that conceal it. It may simply lie beyond the scope of what governments are capable of understanding, acknowledging, or responding to. The assumption that contact with extraterrestrial intelligence must be unmistakable is deeply ingrained in human thinking. Images of landing craft, explicit messages, or undeniable technological demonstrations dominate cultural expectations. Under this framework, the absence of clear confirmation is taken as evidence that contact has not occurred. This assumption may be flawed. Contact does not require clarity. It does not require intent to inform. It does not even require mutual recognition. In many systems, interaction occurs asymmetrically. One side observes, influences, or probes, while the other remains unaware. If extraterrestrial intelligence exists and operates at a level far beyond human comprehension, contact may have already taken place without being recognized as such. Human history provides a useful analogy. When technologically advanced societies encountered less developed ones, contact was not always immediately understood by the latter. Artifacts were misinterpreted. Motives were misunderstood. Entire encounters were absorbed into mythology, religion, or folklore rather than recorded as factual events. A similar dynamic may apply on a cosmic scale. If non-human intelligence interacts with humanity in subtle, indirect, or non-symbolic ways, its actions may not register as communication. They may appear as anomalies, coincidences, or natural events. Without a shared framework for interpretation, contact dissolves into noise. One possibility is that contact has occurred through signals that were received but not recognized. The search for extraterrestrial intelligence has historically focused on narrow frequency ranges, specific modulation patterns, and assumptions about intentional broadcasting. Signals that do not conform to these expectations are often discarded as interference or statistical artifacts. A message that does not resemble a message is indistinguishable from background noise. Advanced intelligence may not encode information linearly or repetitively. It may use complex, non-obvious structures embedded in natural signals. Such encoding could be informationally dense yet appear random to unprepared observers. Without the appropriate decoding framework, reception would occur without comprehension. Another possibility is that contact has taken place not through communication, but through influence. Small perturbations introduced into complex systems can produce large downstream effects. Human civilization, technological development, or even biological evolution may have been nudged rather than instructed. Influence leaves no sender. In this scenario, contact would not involve exchange but guidance. Not commands but constraints. Humanity would remain unaware of external involvement, interpreting outcomes as the result of chance, innovation, or necessity. There is also the possibility that contact occurred but was lost. Human civilization has experienced repeated disruptions: climate events, pandemics, wars, and societal collapse. Knowledge has been destroyed, libraries burned, and records erased. If early contact occurred in pre-technological societies, it may have been preserved only in symbolic or distorted forms. Mythology, religious texts, and oral traditions may contain echoes of encounters that were never intended to be preserved accurately. Over time, such accounts would be stripped of context and credibility, relegated to cultural artifacts rather than historical evidence. This does not imply that myths are records of extraterrestrial visitation. It suggests that contact, if it occurred, may not survive the filtering mechanisms of human memory and interpretation. Another disturbing possibility is that contact occurred and was intentionally erased. This erasure need not involve conspiracy or global coordination. It could be the result of selective attention, institutional bias, or the natural tendency to disregard data that does not fit existing paradigms. Scientific progress often advances by rejecting anomalies rather than embracing them. Data that cannot be explained is often set aside. In this sense, humanity may already possess fragments of evidence that were dismissed, forgotten, or misclassified. The boundary between ignorance and knowledge may be thinner than assumed. Contact may also be ongoing but imperceptible. Advanced intelligence may interact with humanity through channels humans do not associate with agency. Statistical distributions, emergent behaviors, or environmental constraints. The effect would be real but attribution impossible. A civilization does not need to announce itself to exert influence. The most unsettling interpretation is that contact has occurred, but humanity failed to respond appropriately. If contact required recognition, comprehension, or ethical maturity, humanity may simply have missed the opportunity. The moment passed unnoticed, and the conditions for further interaction were not met. From this perspective, silence is not a starting point, but an outcome. This reframing challenges the narrative of humanity as an isolated seeker reaching out into an empty cosmos. It suggests instead that humanity may be a participant in a process it does not understand, responding to stimuli it cannot identify, evaluated by criteria it cannot perceive. Contact, then, is not a future event to anticipate. It is a past or present condition to recognize. If this is true, the absence of evidence does not reflect the absence of interaction. It reflects the limitations of human interpretation. The signals may have arrived. The influence may have occurred. The observation may be ongoing. The question is no longer whether extraterrestrial intelligence has reached out. The question is whether humanity was ever capable of noticing. Among all proposed solutions to the question of extraterrestrial silence, the dark forest hypothesis is often considered the most disturbing. It does not rely on rarity, concealment by benevolence, or incompatibility of perception. Instead, it assumes that intelligent life is common, and that silence is a rational response to danger. The name derives from an analogy. The universe is a dark forest, and every civilization is a hunter moving silently among the trees. To reveal one's position is to invite destruction. Survival depends not on communication, but on concealment. At its core, the dark forest hypothesis rests on a small set of assumptions. First, that survival is the primary objective of any intelligent civilization. Second, that resources in the universe, while vast, are finite relative to the potential number of civilizations. Third, that it is impossible to reliably determine the intentions of another civilization across interstellar distances. These assumptions lead to a grim conclusion. In a universe where intelligence is widespread, caution becomes paramount. Any detected civilization represents a potential threat. Even if it appears peaceful, its future intentions are unknowable. Technological development is unpredictable. A civilization that is harmless today may become dangerous tomorrow. From this perspective, preemptive action becomes rational. Silence, therefore, is not a sign of emptiness. It is camouflage. Civilizations that reveal themselves risk elimination by those who detect them first. Over time, only those that remain hidden survive. The universe gradually evolves toward quietness not because intelligence disappears, but because it learns. This dynamic creates a self-reinforcing pattern. Loud civilizations are removed early. Quiet ones persist. Observers, including humanity, encounter only silence and conclude that they are alone, a false inference produced by selection bias. In such a universe, active search may be dangerous. The act of broadcasting signals into space, as humanity has done, may be interpreted as recklessness. From a dark forest perspective, humanity has already announced its presence without understanding the risks. The absence of response may not indicate safety, but delay. Advanced civilizations may wait. Waiting confers advantages. Observing a developing civilization allows assessment of its technological trajectory, aggressiveness, and potential threat level. Intervention can occur later when it is easier and safer. Silence, in this sense, is strategic patience. The dark forest hypothesis also explains the absence of visible megastructures. Large, detectable constructions serve as beacons. They advertise existence. In a hostile environment, such visibility is a liability. Survival favors minimal footprints and rapid concealment. Expansion does not require visibility. A civilization that masters efficient resource use, stealth technologies, and indirect expansion could spread widely without leaving obvious traces. Influence may replace occupation. Control may replace presence. This introduces a chilling reinterpretation of cosmic order. The universe may not be governed by cooperation or curiosity, but by deterrence and fear. Trust becomes impossible when stakes are existential and information is incomplete. From this viewpoint, contact is not delayed, it is avoided. Critics argue that the dark forest hypothesis projects human fears onto the cosmos. It assumes competition where none may exist and hostility where cooperation could be possible. Yet this criticism underestimates the role of uncertainty. Even benevolent civilizations cannot assume benevolence in others. In game-theoretic terms, the cost of being wrong is extinction. Under such conditions, rational behavior converges toward silence. Not because hostility is universal, but because trust is too risky. A single aggressive civilization is sufficient to make caution the dominant strategy for all others. Humanity, as a young civilization, may not yet recognize this logic. Its optimism reflects inexperience rather than safety. The dark forest hypothesis also casts a new light on humanity's future. As detection capabilities improve, the temptation to actively search for extraterrestrial intelligence will grow. Yet each improvement increases exposure. Every signal sent is irreversible. Once location is known, it cannot be unknown. This creates a paradox. The desire to know may conflict with the need to survive. In this framework, the silence of the universe is not something to be solved or broken. It is a warning encoded in absence. The lack of signals is the signal. Civilizations that understand the dark forest remain quiet not out of fear, but out of rational calculation. They do not announce themselves. They do not respond. They do not reveal. Humanity's unanswered transmissions may not be ignored. They may be recorded. The unsettling implication is that humanity's search for companionship may be interpreted as vulnerability. Curiosity in a dark forest is indistinguishable from exposure. If the dark forest hypothesis is correct, then the question, "Why don't we see aliens?" has a simple answer. Because those who are seen do not survive. After decades of observation, speculation, and analysis, the question of extraterrestrial intelligence remains unresolved. The universe appears silent, empty, and indifferent. Yet the accumulation of hypotheses explored so far suggests that this appearance may be profoundly misleading. Silence, once assumed to be evidence of absence, emerges instead as a complex and ambiguous signal. Each explanation, temporal separation, post-biological intelligence, hidden dimensions, underwater civilizations, deliberate observation, strategic concealment, offers a way for intelligence to exist without being seen. None require extraordinary assumptions on their own. Together, they form a coherent pattern. The pattern is not one of emptiness, but of inaccessibility. The most unsettling realization is not that humanity is alone, but that it may never have been meant to notice others. Detection presupposes compatibility, shared assumptions, shared modes of existence, shared frames of reference. Yet intelligence, once it surpasses certain thresholds, may diverge so radically that compatibility collapses. At that point, contact ceases to be inevitable. Advanced civilizations may not expand outward in visible ways. They may not communicate. They may not even occupy space or time as humans understand them. Progress may lead away from visibility, away from interaction, and away from material presence altogether. What remains detectable is not intelligence, but its absence. Humanity, then, may be observing a universe shaped by intelligence that has already moved beyond the observable domain. This reframes the Fermi paradox. The question is no longer where is everyone, but where did everyone go, and why does it look like nowhere at all? The answer may be that they did not go anywhere. They simply ceased to be visible. Another possibility is more unsettling still. Humanity may be early. Not early in the sense of cosmic timing, but early in development. The traits that define human civilization, expansion, communication, signaling, exploration, may be characteristic only of immature intelligence. Curiosity may precede caution. Visibility may precede survival. If so, the silence of the universe is not a mystery to be solved, but a lesson to be learned. Civilizations that survive long enough may converge towards similar strategies, minimizing exposure, avoiding detection, and limiting interaction. Whether driven by danger, ethics, indifference, or transcendence, the outcome is the same. The cosmos becomes quiet. Humanity, standing at the threshold of technological maturity, may be facing a choice it does not yet recognize. Continue signaling, expanding, and announcing its presence, or learn to listen to the silence as information. The most disturbing answer to the original question may be the simplest. What if we do not see aliens because there is nothing to see? Not because intelligence is absent, but because intelligence does not look like anything once it reaches a certain point. No chips, no signals, no structures, no visitors, only processes, constraints, and patterns that blend perfectly into reality. At that stage, intelligence becomes indistinguishable from the universe itself. If this is true, then humanity's search is fundamentally misdirected. It looks for neighbors when it should be studying architecture. It listens for voices when it should be analyzing structure. It seeks messages when it should be questioning assumptions. The silence, then, is not an invitation to speak louder. It is an invitation to rethink. There is also a more personal implication. Humanity often frames contact with extraterrestrial intelligence as validation, proof that it is not alone, that it matters on a cosmic scale. But a universe filled with intelligence that chooses not to engage offers no such reassurance. Meaning, in that case, must be constructed without witnesses. This may be the final test. Not technological, but philosophical. A civilization capable of accepting its isolation without despair, curiosity without recklessness, and silence without projection may be one that is ready for whatever comes next, even if nothing ever comes at all. The universe may not be hostile. It may not be empty. It may simply be indifferent to being known. And perhaps the most unsettling conclusion is this. The moment humanity understands why it cannot see others may be the moment it, too, begins to disappear from view. not through destruction but through evolution. The silence of the universe may not be a failure of discovery. It may be the final stage of intelligence.